Welcome to Byte-Sized Tech, where we blend casual conversations with insightful discussions on the latest in technology and gadgets. Today, we're diving deep into some really compelling stuff happening right now across tech. We're looking at, well, how AI is basically gobbling up power, this huge global race for tech dominance, and even how robots are getting into eye surgery. Seriously, get ready for some, aha moments, some real eye-openers.
Yeah, it's great to be here to unpack all this. We'll dig into the details behind these big headlines, try to connect some dots, and figure out what it all means for you, the listener, and, well, for where innovation is heading. Things are moving incredibly fast right now.
Okay, let's kick things off with power. The AI boom needs just a ton of energy. It's like this amazing new thing, but it's incredibly hungry. And our power grid is, frankly, struggling. We're hearing about data centers waiting in line for years, sometimes like 5, even 10 years, just to get plugged in. That's a massive bottleneck, right?
It's a huge problem, an unprecedented hurdle, really. And that's exactly why this partnership between Crusoe and Red Materials is so, well, interesting. They're basically tackling it head on, building AI data centers completely off-grid.
Off-grid. How does that even work for something so power-intensive?
So they have these things called Crusoe Spark. Think mobile modular data centers. Each one packs about 500 GPUs, the really powerful chips AI needs. And for the site we're talking about, they've got 4 units planned, totally independent from the main grid.
Okay, mobile data centers, fine. But the power source? If it's not the grid, then what?
Right. This is the clever bit. It's powered by on-site solar, and get this, end-of-life EV batteries. Used par batteries, essentially.
Wow, really?
Yeah, and it's not some tiny experiment. This setup is already the biggest microgrid in North America, and it's the world's largest deployment using second-life batteries like this.
That's genius, using old EV batteries, so it's sustainable and solves a waste problem. But the speed. You mentioned those crazy long queues for the grid. How fast did they get this thing up?
Get this. About 4 months, from idea to fully operational.
4 months.
Yep. Compare that to waiting 5 or 10 years. It's night and day. And here's another twist. They call it a negative green premium.
Negative green premium. Okay, what does that mean? Sounds like jargon. Does it mean it's cheaper?
That's exactly it. This sustainable off-grid power is actually cheaper than getting power from the grid in places like Northern Virginia, which is a huge data center hub.
Cheaper. So green energy is actually saving money here.
In this case, yes. It kind of flips the script, doesn't it? That green always costs more. And Redwood Materials, the battery partner, they're already the biggest battery recycler in North America. They have gigawatt hours of batteries lined up for reuse. They're talking about projects 20, even 100 times bigger than this one. The potential scale is just huge.
So, okay, stepping back, what does this mean for you listening right now? It's not just about faster AI, is it? It sounds like it could make AI available, well, almost anywhere, powered sustainably, not just in these giant grid-connected facilities.
Exactly. It could make advanced AI much more ubiquitous, much more accessible, a really fundamental shift.
Right, and that push for more AI everywhere, that just fuels the global tech race, doesn't it? Which brings us to the next big topic. This intense competition, especially U.S. versus China, feels like it's heating up fast.
Oh, absolutely. It's definitely heating up. And China's made some moves that have frankly surprised a lot of people. Take a startup called DeepSea. They came out with a product claiming it matches or even beats Western AI models, but at a tiny fraction of the cost.
It's a fraction of the cost. Wow.
Yeah, that was a real aha moment. As you said, it really showed how quickly things are changing and the capabilities being developed over there.
And it's not just about who has the smartest AI model anymore. It feels broader.
Much broader. People are calling it a tech Cold War. The competition covers standards, governance, the actual infrastructure, and despite things like export controls on ships, the U.S. lead seems to be shrinking. Some reports say Chinese companies have doubled, even quadrupled their capabilities in a year.
Doubled or quadrupled? That's insane speed.
It is, and you're seeing Chinese companies aiming global. Like Manticore, one of their 6 little dragons in spatial design software. They're about to go public internationally. First of that group.
So they're not just catching up, they're pushing out onto the world stage. What about the established players like Japan and the chip world? Are they worried?
Well, interestingly, Tokyo Electron, a huge player in chip-making gear, they seem pretty calm about it. Their CEO basically said they'll just innovate faster to stay ahead. Japan still plays a critical role in high-end tech, even though their overall market share isn't what it was back in the 80s, It went from like 50% down to 10%.
Still crucial, though.
Definitely. And a key factor for China we have to mention, is their talent pool. Over 17 million engineers.
17 million.
Yeah, it's a massive engine for innovation.
Okay, so with all this rapid progress on both sides, does it have to be a fight? Or could everyone benefit somehow?
That's the million-dollar question, isn't it? Some folks argue it's pointless to compare apple with orange. The idea is maybe the world benefits if we use the strengths of both, like the U.S. leads in core computing chips, maybe China leads in applying AI, building out the infrastructure.
Leveraging strengths.
Right. And another big trend is open source AI. Companies like DeepSea, Alibaba, they're releasing their models openly. This could lead to a more, let's say, positive race, fostering decentralized AI that's maybe more efficient and benefits more people.
Okay, but we can't talk AI without talking NVIDIA. They're still the giant in the room, right? Approaching some mind-boggling valuation.
Oh, absolutely dominant. They're hovering around, what, $3.83 trillion market cap?
Wow.
Yeah, they need about $164 a share to hit $4 trillion. It's staggering. And that's driven by just massive spending from cloud companies, even governments buying up their GPUs like crazy. It's an AI arms race for chips.
So how do they stay on top with everyone gunning for them?
Well, they're being quite clever. They're opening up their platform, CUDA, to support other chips too.
Oh, interesting. So not just locking people in.
Exactly. It's seen as a smart move. It lets others, maybe using custom chips or even competitors like AMD, still work within NVIDIA's ecosystem. It helps them maintain that leadership position, even with all the competition. They're executing really well.
So for you, the listener, what's the big picture takeaway from this global tech race? It sounds like crazy fast innovation, maybe more choices, but also potentially different tech paths developing globally, like a split.
That's a real possibility. Different ecosystems, different standards, depending on where you are, what tech you use. It's complex, and it's unfolding right now.
Okay, let's zoom in now. From the big global picture to how AI and robotics are actually changing things on the ground. In industries, in our lives.
Yeah, some really amazing stuff happening in medicine. Take Foresight Robotics. They're building a robotic system to tackle the vision crisis.
Vision crisis, that sounds dramatic.
Well, the numbers are pretty stark. 2 billion people globally have vision impairment. That's a nearly $3 trillion economic hit.
2 billion.
And think about cataracts. It's the most common surgery in the world. But there are maybe 600 million people who need it, and only about 30 million procedures get done each year. The CEO said flat out, there is no human way to close this gap.
Okay, so robots are the answer. How does that work for something as delicate as eye surgery?
Their system aims to basically augment the surgeon, make them more precise, more capable. The goal, in their words, is to transform the average surgeon into the Michael Jordan of surgeons.
High praise.
It is. Technologically, it's this blend of superfine micromechanics and a really smart software brain. They're using NVIDIA's computing power, actually, for that micro-level precision.
And is this real? Is it being used?
They've done over 3,000 procedures on animal models, which is a lot. And they're planning the first human trials for later this year. They also landed the second largest Series B funding round ever for surgical robotics. So yeah, there's huge confidence behind it. The potential impact on global health is massive.
Yeah, incredible. Life-changing stuff. But AI isn't just healthcare, right? You mentioned critical infrastructure, too. Palantir and nuclear power.
That's right. It's a big national security issue, too, because China is actually on track to become the world's biggest nuclear power producer, overtaking the U.S.
Really? I didn't know that.
Yeah. So Palantir is working on AI software to help build new nuclear facilities faster and more quickly, basically using AI to manage the complexity and boost productivity in construction.
Makes sense. And the big tech companies are all over AI, too. Meta. What are they up to?
Well, besides their big AI models, they're reportedly looking to buy a startup called Play AI.
Play AI. What do they do?
They specialize in using AI to replicate voices, realistically. So the idea is this would boost Meta's chatbots, maybe their Ray-Ban smart glasses, hands-free interaction.
Yeah.
And they could potentially integrate it into their open-source Llama model, too.
Ah, so better voice assistants, maybe.
Probably. It fits with Meta's whole strategy. They've basically said they plan to overspend on AI to try and lead the pack.
Right. Okay, quickly on a lighter note, gadgets. This Trump mobile phone. There was some buzz about it being made in USA.
Yeah, that wording got quietly changed on your website. It originally said made in USA. Now it says something like brought to life right here in the USA with American hands. Subtle difference.
Very subtle. It's widely thought to be actually made in China, probably based on a model by a company called WingTech. Just a little reminder about marketing versus manufacturing reality sometimes.
Gotcha. So pulling this section together for you, the listener, AI isn't just some future thing. It's getting woven into everything. Life-saving surgery, powering the grid, how we talk to our devices. It's becoming fundamental.
Deeply embedded, absolutely.
Okay, final segment. Let's pivot to another really dynamic area. Crypto. For ages, it felt like the industry was facing a pretty tough regulatory climate in the US, right? Definitely. Often described as hostile, yeah.
Yeah.
Which is why what's happening right now in Congress is actually quite significant, maybe even historic. You've got two major bills, one for stablecoins, one for general crypto market structure moving forward at the same time.
Two bills at once.
Yeah, and they're trying to advance them together with a single procedural vote. That kind of parallel movement for big legislation in one industry is pretty rare. It signals a real potential shift.
Okay, so if these pass, what do they actually do for the industry? And, for regular people, maybe using crypto?
The big thing is clarity. They provide a much-needed legal framework. For the innovators, the builders, it gives them regulatory certainty, which they haven't had. It lets them operate without constantly looking over their shoulder. And for you, the user, the person buying or selling crypto, it introduces really important safeguards, things like consumer protection rules that are largely missing right now.
So better rules for companies, better protection for users. Sounds like a good balance.
That's the goal. Foster innovation, but make it safer for everyone involved.
And I heard this term, the dollarization thesis, connected to the stablecoin part. What's that about?
Right. So for stablecoins, those are cryptos pegged to currencies like the dollar. This legislation is seen as really key. There's a national security angle here. The U.S. wants the dollar to be the main currency backing these global stablecoins. Passing clear rules makes the U.S. an attractive place for stablecoin companies to set up shop, which helps keep the dollar central in this growing digital finance world. It's strategic.
Got it. So it's about keeping the dollar relevant globally in the crypto age.
Exactly. Reinforces its position.
Okay, so the final takeaway for you on crypto regulation. It looks like we're heading towards a clearer, maybe safer way to engage with digital money. Innovation gets a runway, but with guardrails for consumers. A potential turning point.
A very significant turning point, potentially.
So wow, what a journey today. We really covered a lot of ground. From AI's massive energy needs and clever solutions, through that intense global tech race, then down to actual robots doing surgery and AI managing nuclear plants, and finally this big shift in crypto rules.
It really shows how interconnected everything is and how fast tech is weaving itself into, well, everything. Which leads to a final thought, maybe for you to mull over. As AI gets everywhere, integrated into daily life, how do you see the balance playing out? The balance between all the convenience and innovation we get and the sort of hidden machinery behind it, all the energy demands, the global politics, the regulations needed to make it work. It's something worth thinking about.
Absolutely. A great question to end on. Something profound to chew on. Thanks so much for tuning in to Byte-Sized Tech. If you enjoyed the deep dive, please like, comment, share, and subscribe for more fun tech discussions.